All right, well, good evening, everybody. My name is Zach, KC1SES. Welcome to a primer on the Nano VNA. Quick disclosure, I'm a general operator. I'm learning this just as everyone else in this room is. I just happen to have done a little bit more research than a lot of other people, and that's fine. There's going to be some references at the end. I highly recommend that you look at those if this is a product that interests you, because it is a solid tool. And those resources will give you a lot of information that I physically can't in an hour and still have some degree of hands-on time. So first, what is a VNA? VNA stands for Vector Network Analyzer, and it's used to measure electrical networks, which I'll explain in a second. Typically, these will cost a couple of grand for a decent used one to up to like $250,000 for really high-end ones. We don't need that level of accuracy. What can it measure? It can measure things like SWR, complex impedance, components values, feed line length, distance to fault, filter shape and loss in feed line, delay in the device under test, amplifier gain, and frequency response, allowing you to test things like antennas, duplexers, diplexers, filters, inductors, capacitors, amplifiers, splitters, baluns, ununs, chokes, phasing, networks, attenuators, etc., etc. Basically, it is a very affordable device that is going to allow you to test a lot of things that you're going to spend a lot of money otherwise in order to test. It's going to be a great device. So what is a Nano VNA? Let me see if I can shrink that real quick. There we go. It's a small vector network analyzer. I'm going to go ahead and pass this one around. Hand it around. Feel free to, it's a touchscreen. You can feel free to press buttons, explore a little bit. The one that I have is the NanoVNA V2-H. It has a frequency range of 10 kilohertz to 1.5 gigahertz. This will vary based on devices. Your F model, what does your F go up to? You know off the top of your head?
I think
3 gigahertz. Yeah, you can get some, and I know that there are some that'll go up to like 6 if you want to spend a couple $100s. These are very affordable. The one that I caught, I bought with all the accessories that are necessary to make it work. It cost me $60 out of pocket on Amazon. The PowerPoint will be available for anybody after the presentation who wants access to it, and I do have a link directly to the one that I bought, and that's where I'd recommend going to start. There is a USB port on the Nano VNA, which will allow you to connect it to a computer and use software that really takes the features of it and just kind of explodes it, makes it a lot easier to use and show a lot more information. It is based on open source firmware and hardware. Like I mentioned, the VNA is a very widely used tool in a lot of engineering circles, but it's very expensive. And so a bunch of engineers decided they wanted to have something that was available for the layman just to be able to buy and operate. And as a result, us hams got a really good deal. A quick note that I want to make is there's 101 data points. So whenever you're doing a calculation with the Nano VNA, you're getting 101 points. So if you go from 1 megahertz to 1 gigahertz, you are getting 101 points within that. So it's going to be very wide between those points. It's going to be very inaccurate as a result, which is why you're going to want to test in smaller ranges, which I'll get into a little bit later as well. What can it measure? It's basically the same slide as the other VNA. The only thing I'll mention is that rubber duckies do these do very poor job of measuring rubber ducky antennas. I have tried like 5 times to measure this thing, and it looks like it's above a 4-to-1 on every single frequency known to man, so it's kind of ridiculous. But it is very useful for SWR, for HF antennas. This antenna here, I pulled off of my buddy's roof because he wanted to get rid of it when he bought the house. Turns out it's a GMRS antenna. It's great for me. And I got 50 feet of LMR 400, which I used this to test and was able to verify that it works out well. Can I get rid of this little bar here? All right, I can. So this is a basic representation of what a Nano VNA is inside, and for that matter, what a vector network analyzer is. As you'll notice as it's getting passed around, there's 2 ports. In the case of this, we'll call it port 1 and port 2. So if the device under test is an antenna, you're just going to connect to 1 port like you would with an SWR meter. So what's going to happen is it's going to send the signal out, and it's going to hit the antenna. It's going to have the bounce back, whatever is happening with your particular antenna setup. And that reflected power is going to be measured, and the SWR graph is going to be shown, or your cable loss, et cetera, whatever it is that you're testing. And then if you're using something like a filter or a duplexer or something along those lines, I guess those are probably the same thing for all intents and purposes, you'll connect the output port of that device to the secondary port on the Nano VNA, and you can connect that link. So for $60, you can actually tune a duplexer for a repeater pretty darn well. It's not going to be quite as accurate as a several $1,000 VNA, but for most of our use cases, it's going to be more than fine. This is a chart showing the SWR of the folded dipole antenna at the Cumberland County bunker. You'll notice that it does pretty well on 80, 40, 20, 10. It's not too great on 60. It's surprisingly good on 30, 17, 15, and 12. And then I have a narrower, view here. And this is just the 80 meter band. So you see it's above a 2.33 and drops down to a 3.995 at the end. And if you notice on the right, there's a little bit of a hiccup there. I do not know exactly what that was that happened when I did the test. And frankly, I didn't feel like rerunning the test. Could have been a number of things. I could have touched the coax shield. That could have interrupted it. I could have moved the VNA. It could have been something in the software. It is a $60 device. You're going to have little hiccups like this. But overall, it's very close. I mean, that's a difference of 0.05 on the SWR. Like it's pretty minuscule. All right, getting started. So as it's passed around, you'll notice there's a USB port, there's an on-off switch, and then there is a little dial on the top. You press once to open up the menu system or to select something in the menu, and you can rotate it side to side to go through the menu. If you are looking at, say, an SWR chart and you want to move along because you want to see what it is at any given frequency, you'll rotate that knob to find that frequency. A lot of information here. You don't need to memorize this. Basically, when you get started, your touchscreen might need to be calibrated. If you find that you're pressing it and it's just going haywire, it probably needs to be calibrated. It's a pretty straightforward process. You'll open the menu, you hit config, touch calibration, you touch top of the screen, bottom of the screen, and you hit save. Pretty straightforward, but I wanted to mention it. A lot of people get turned off on the Nano VNAs when they first turn it on and they see like 4 different graphs. You might see a log mag for cable loss, you might see a gain, you might see a Smith chart and SWR all on top of each other. It can be very overwhelming. And for me, at least when I first turned it on, I was like, what did I just buy? This is a lot. I really wish I could get rid of this little top thing. Oh, I can. There we go. Perfect. So this is talking through what is on that little display. I say little, there's different versions of Nano VNA, as I mentioned. We've got a 4-inch here that Brian has. Mine is a 2-inch. The 4-inch is going to cost you a little bit more money because it's a larger device. You'll notice this one is testing SWR resistance and reactance. And you'll notice the one in the middle, that is where your current reference position is on the trace. Each of these are called a trace when you're looking through. And you can have up to 4 of them on at any given point in time. And then at the top, you'll see your current frequency position for your marker, and you'll see your trace status. So in this case, channel 0, which is your first port. Sometimes you'll see it channel 1 and 2. Sometimes you'll see it 0 and 1. It just depends on how that manufacturer decided to label their product. It's a pretty common thing to see in computers. You'll see your format, you'll see your scale, and you'll see your value. So what this is saying is each one of these lines is, I believe, 1 level of SWR, so 1, 2, 3, 4, etc. And the current value is 3.7. On the bottom, you'll see your sweep frequency is 3 to 4.3 megahertz. You can set that to be your entire range. For example, I sometimes will use mine at 50 to 1.5 just because I want to see everything that it sees. Other times I'll run it between 2 and 30, or I'll just run it 140 to 150, whatever the range is that you want to be using at that point in time. Oh, come on. Sorry, I was not prepared for the Zoom part to be here. So on the menu system, one of the first objects you'll see is display. And then if you tap trace, you'll have your 4 trace options. In this case, it's 0, 1, 2, and 3. And you can see you have 2 different log mags, you have a Smith chart and a phase. Like this is what you're going to commonly see when you first buy a VNA, you power it up and this is what comes on it, which is a lot of information for most people. By tapping the trace icon, you can turn them all off. One of the things I recommend is the first thing you do, turn off every trace but 0, and then you're just going to see your SWR because that usually is the defaulted trace 0. One of the other things that people tend to, come on. Wow, this computer is chugging along. Come on, there we go. One of the other things that people tend to get turned off by is you have to calibrate this. If you go out and you get an antenna analyzer, you pop your piece of coax, it connects to your antenna, you're up and running. With the Nano VNA, you do have to calibrate it, and you have to calibrate it pretty frequently. You can't just calibrate it once and be done with it. This is because the factory can't determine your conditions of use. Something called the calibration and reference plane will change, which I'll explain in a second. And then because it's lower cost, you do have lower accuracy, and sometimes components change as they heat up, as they cool down over time. And so having the ability to calibrate these as you go along is very useful. To put it in perspective, high-end VNAs also need to be calibrated. So if you have that $250,000 VNA, your calibration standards, which are a 50 ohm load, a short, and an open connection, might cost you $80,000 because it's very, very scientifically accurate. These ones are literally just SMA connectors, which I will show in a moment. This is the kit that I purchased. You'll notice we have the short, open, and load, as well as a female-to-female barrel, and then 2 jumpers, USB cable, and a couple of styluses if you choose to use that instead of your fingers, which the screen this size, it does tend to be helpful. So this is what I was referring to when I said calibration plane. Now on the left, we have a vector network analyzer of some kind. That could be a VNA, it could be something else. You have a DUT, which is device under test. In this case, we'll say it is a bandpass filter that you're trying to test. Now, if you hook up and you calibrate your standards directly on the ports right here, that's great. The moment you need to connect a cable to a device, if this was a SMA to BNC or PL259, et cetera, to connect to, say, a bandpass filter or a duplexer or something along those lines, suddenly you have this coax that's going to introduce loss. One of the nice things about calibrating VNAs in general is you can calibrate, instead of calibrating to here as your reference plane, you can calibrate out to here. So what I do is I connect a little barrel and I put my calibration standard here. As a result, this entire cable might as well be inside of the VNA. It is invisible to you. The device will see it, it will interpret it, and it will remove it from its calculations. Where this can become helpful, say you have an antenna, you don't really care about how much loss you're incurring from your cable in this instance. You just want to know exactly what the SWR of your antenna is. As many people know, if you have a lossy cable feeding an antenna, your SWR is going to be better. It's going to seem to be better because that loss is happening and you're not getting that reflected power back. You could calibrate out that entire cable length, and then the only thing that you're actually measuring is the antenna itself. Also, if anybody has questions at any point in time, please let me know. I tend to talk fast. I am hoping to get to a little bit more of a hands-on demonstration. So I'm trying to kind of brush through a lot of the theory and the ideas behind it. You're doing great. Thank you. As mentioned, there's port 1 and port 2. Now, one of the confusing things you may notice is S11 and S21, and I skipped this on the slide earlier. What happens is you can look at it as SXY, where you are measuring signal Y generated from port X. So in the case of S11, you are connecting one device. So this is what you would use for testing SWR. You're connecting one cable, you're generating a signal on port 1, and then you're measuring the same signal on port 1 when it comes back and seeing what the differences are and making your calculations accordingly. 2.1, you are measuring the signal on port 2 that's being fed from port 1. So in the case of a filter, you're producing a signal on port 1, it's going through the device, the filter in this case, and then on port coming through into port 2. Or in this case, channel 0 and channel 1. Again, that's going to vary a little bit depending on the device you get. Calibration. Again, this looks like a lot. It's pretty straightforward. You open up the calibration window, and then you literally you connect your open standard, and you tap open. You take your open off, you connect your short, you tap short. You take your short off, you put your load on, you connect your load, or you connect your load, you tap load. Isolation is basically, you put the load on one and it tests the difference between the 2 ports. And then the through port will actually be a connection where you will connect the cable from one port to the other. And you have to do open, short, and load for any calculation you're doing. So if you're just doing SWR, that's all you need to do. But if you're going to test something like a filter or anything that requires 2 ports to be connected in and through, you'll need to do the configurations for the isolation and the through. Make sense? Couple of things that really confused me, and I'm going to do my best to explain this. The Nano VNA has 101 data reference points. When you were doing a calibration for a given range, you are going to take 101 evenly spaced points between that range. The Nano VNA will extrapolate the data in between, and it will do its best to guess. But the more data points you have, the less distance between in terms of megahertz or kilohertz, whatever the signal is, that you have between your two data points, the more accurate Nano VNA is going to be able to be. So if you're testing, for example, the entire band, the HF band from 2 megahertz to 30 megahertz, you're going to have a 277 kilohertz per between each data point, which is pretty wide. So if you want a broad understanding of what your antenna looks like, that's great. You can do that. But if you really want to dive into, say, how 20 meter works, and 20 meters is currently my favorite band, I would set it to say 13.9 to 14.4, which is a little bit on either side. And if that's the case, you now have 4.9 kilohertz between each of those segments. It's going to be a lot more accurate because those data points are closer together effectively. Make sense so far? Now, if you do, say, 50 megahertz all the way up to 1.5 gigahertz, you're talking megahertz steps, which when you have 350 kilohertz for an entire ham band, you lose that pretty quickly. So, makes sense on the calibration? Any questions on that? Because that's one of the biggest things that makes people have hiccups. And again, everything that I'm talking about, all of these images, for example, are actually out of a PDF manual. I just copy and pasted because I said I can't do it better than they did. It's going to be in the references. I recommend having that on hand when you do, if you get a VNA, which again, I highly recommend doing. I was looking at antenna analyzers, and just to get something that'll cover just HF, not VHF or UHF, was $300-400 to get like a decent high quality one. $60 does the same thing.
And you have to buy all the testing equipment. So
yeah. So that's a good point. And I was going to say this later, but I'll say it now. You can get VNAs for like $20-30 on eBay or Alibaba. Wherever you buy them, make sure you get the calibration standards. I think that what I just said, I hope explains why you need the calibration standards. If you don't have them, you're going to have all kinds of wonky results. We did a POTA activation with the buddy poll. Thank you. And the test results we were getting were just all over the place. And I'm pretty sure it's because it wasn't properly calibrated.
Yeah, it's never been calibrated because it didn't come with the parts.
It didn't come with the parts, and you didn't know that it needed to. Yeah. That's why I'm emphasizing you got to calibrate your VNAs. So anybody who knows anything about Smith charts will know what an open, a short, and a 50 ohm load are supposed to look like on the Smith chart. If you don't, these are what they're supposed to be. If you're
calibration, that'll be in there eventually.
Okay. Well, actually, I picked that in.
I'm gonna mute the TV for a moment. There it is.
Yeah, I know.
Oh, there we go. Did you mute him there? Oh, thank you. All right. If you want to test and make sure that your calibrations are good, you can take a look at your Smith chart. In fact, you can actually have your Smith chart up and open while you are doing your calibrations. And when you plug that in and you calibrate it, you can see if it's in the right spot. So, steps to take a measurement. I'm going to go over this real broad. It's probably going to be a little confusing, but here we go. First of all, you're going to select the traces that you want. Like we mentioned earlier, you can have up to 4 traces. So say we're just doing SWR. You're going to turn everything off except for trace 0. You're going to go into the menu and you're going to choose what option you want. I have a cheat sheet in here that shows the menu system. Once you start getting into it, it's not super hard. It's just kind of the same thing in just different places. So you'll set SWR, you'll set the scale that you want, say 0.25 in my case for most of the time for smaller measurements. You're going to select your trace channel. So channel 0 reflector, channel 1 through. So depending on what you're doing, if you're doing SWR, you just want channel 0. If you're doing something like a filter, you'll want to do channel 1, so you have the through port there. You'll want to select your scale, and then you'll want to select your stimulus range. The stimulus range being your, say, 14 or 13.9 to 14.4, or your 2 to 30, whatever that may be. Because when you do the calibration, it is going to take that information and it's going to be looking for that stimulus range. Let me phrase that. It's going to be calibrating to that stimulus range. You can save, I believe, 5 calibrations in the Nano VNA. The first slot will be what it automatically loads up to. So you don't have to do a calibration every time you take it out. For my example, I have 2 to 30 megahertz on slot 1, 140 to 150 on slot 2, UHF on slot 3, and then VHF is just 20 meters. So if you have something that you're doing a lot of, say you're building a 20-meter dipole, and you know that you're only going to be measuring that, you can set one of those calibrations and then you can reload that every time instead of recalibrating every single time you turn the device on. But it is important that you set your stimulus before you do your calibration, because if you calibrate for 2 to 30 megahertz and then you're testing 140 to 150, all of your calibration is going to be completely irrelevant. It's going to do its best to extrapolate the data, but it's not looking at good information. And again, I'm going to walk through most of this in a little bit. TDR, I'm going to very quickly skim over this. This is the method in which you can measure coax length or length to a fault in a piece of coax. Basically, what happens is you connect your coax to your VNA, it sends out a known signal, it detects how long it takes for that signal to reach the end and then come back to it, and then it takes a measurement and it will tell you what it is. That piece of coax, the LMR 400 I have, is roughly 50 feet. I think that it measured out to be 14.39 meters or something. It's within a foot or so of what it actually is. It's not perfect. I will also attribute some of that to my calibration. Because of a lack of adapters, I had to introduce a small piece of coax as well into that. And so it kind of threw off the measurements a little bit. This cheat sheet, again, is in the references. This is telling you how you will test a piece of coax to determine its length. I'm not really going to go through this right now because it's going to fall on deaf ears because you can't test it in front of you right now. So that's there. Again, that'll be in the links in the end. Now we're going to get on to where I think the NanoVNA really, really shines. NanoVNA Saver is a great application. This is one of the probably best built currently. There's a couple of them out there for different applications that you can connect a NanoVNA to a computer and run with. NanoVNA Saver is my current favorite. First of all, it's a larger screen. You know, if you have a 15-inch laptop or a 43-inch monitor, it's going to look a lot better than a little 2-inch screen, especially for some aging eyes. And I mean, heck, my 26-year-old eyes prefer a full-size screen than a 2-inch screen. So you can have multiple charts that are not stacked on top of each other. So instead of having 4 traces that are just all on top of each other and really hard to read a ton of information crammed into a 2-inch screen, you can have them in their own individual segments. If you notice on the left, there's a TDR section. It'll actually estimate the cable length. Just like on the NanoVNA, part of the procedure is you put in the velocity factor of the coax cable. What's nice about NanoVNA Saver is you can actually just say what type of coax cable it is, RG8X, LMR 400, LMR 200, whatever the case may be, and it will do that calculation. And then so when you're running the test, even if it's connected to an antenna, it'll actually estimate the cable length for you that's being fed into the antenna. And so if you know what your loss should be in that, you can actually factor that out of your calculations when you're looking at, say, an SWR graph. What else? There is analysis, so you can run specific tests. You can run SWR tests. You can run filters on bandpass filters, low pass, high pass, et cetera, and it will give you some metrics that are harder to just look at a graph and see. And then probably my favorite part of the NanoVNA Saver, I keep talking about 101 data points. As a note, there is a firmware out there that'll do 401 data points instead of 101, but I didn't feel like risking my device by flashing it with custom firmware. It's working, so I'm running it. You can do multiple segments in NanoVNA Saver. So depending on how good your computer hardware is, you can do, say, 20 segments or 200 segments. So instead of having 101 data points, if you do 20 segments, it's 2020 data points. And basically what it does is it will just run a 101 data point test 20 times. It'll do the math of like, this is the frequency range divided by 20. Okay, do 1, 2, 3, 4, 5, 6, onward and so on until you get the full length. You're going to have a lot more data points. It's going to be a lot more accurate. Chances are your graph is going to also be a lot smoother and nicer to look at. And it's going to be a lot more detailed. So that is the majority of that. Not bad on time. This is the menu system. Looks a lot scarier than it is when you actually get into it. I don't like how they designed this, but this is the only reference out there. And then, like I said, I have a ton of links. So if this is something that is even remotely interested in you, there's a handful of those that are in there. The Absolute Beginner Guide is the one that I recommend looking at first. That's where a lot of the screenshots that are in this presentation came from. And then the IMSAI guy, he is fantastic. He's probably the resource that I learned the absolute most from. He's an electronics guy. So he's got, a couple multi-$1,000 vector network analyzers that he compared with the NanoVNA. And this will be available if anybody wants it emailed to them with the link. So you can actually take a photo, but you can also email that too if that's easier.
And we'll put it on the website too, aren't you?
So what I would like to do now is I would like to connect this to my computer and show you NanoVNA Saver and show you a couple of the tests that we can do. I would love to show you on the actual device, but frankly, there's too many of us to crowd around it. And
I need to stop the sharing and reshare with the screen because it's still showing PowerPoint.
okay,
You can just share that out.
thank you for that. All right.
Go back to Zoom.
Yep, and share screen. NanoVNA Saver, share. All right, so it's a pretty straightforward process. This is great if you just want to go out in the field, you're doing a POTA or a soda activation, field day, something like that, and you just want a little device just to do a quick check on. You can run it by itself. 9 times out of 10, I have this laptop set up. I was telling, what's that?
Gonna log anyway, right?
Yeah, exactly. I was telling Brian before everyone came in that I didn't really have any issues with my mobile mag mount antenna, but I wanted to tune it a little bit, check in on it. And I hooked this up with it in the back of my car. I moved the antenna around, I did a bunch of tuning, and I found some really interesting results out of it. All right. So this first cable is a piece of RG8X and a short cable. The first thing I'm going to do, though, I almost skipped the calibration steps. That would have been bad. I'm going to pull out my calibration stickers. I'm going to walk around with these real quick. So the one on the right is the load, then you have the, is the open. And then this is the short, which is basically connecting the outside pin to the inside pin. And then the silver one is the load, which is basically a 50 ohm resistor inside. Brad, did you end up buying standards?
I have not yet.
You have not yet. Shame. All right. So for this instance, I'm going to use a short jumper that came with it. And I'm going to connect the cable onto port 1. And then I'm going to come in. And the first thing I'm going to do, just like on the Nano VNA, can you all see it just well up there? Do I need to like zoom in at all? Yeah, let me adjust that. Yeah, that's better. Oh, wow. That might be a little too big. Let me restart the app. So it's a little.
I'll get the screen sharing done in a second.
Well, it didn't fix it, so.
I think there's like a screen zoom. I don't know if it's powerful or not, but
Yeah, that's fine. Why can't I? All right. So first thing I'm going to come do is you're sharing the screen. Great. Can you get rid of that, please, now? Is I'm going to come down in and I'm going to connect to the device. You can hit rescan here to scan for the device. In this instance, it's port 3. It's a COM port. And then I'm going to hit calibration. A note here on the bottom, you can save calibrations and you can load them. So I'll show you here. I have a 2 meter 10 segment, which is just the 2 meter segment of the band or 2 meter band. And it is 10 segments within that. I've got HF, I've got 50 to 100 or 1.5 gigahertz for the 100 segments. That takes forever to load and most of the time crashes my laptop. Be aware of that if you're using an older laptop. It does require a little horsepower to do that, but most of these doesn't require much. And so I'm going to hit calibration assistant and it's give you a chance to read here. But basically it's saying make sure you have all of the standards. And if you want to do a 2-port calibration, you must have a through connector. And so I'll hit OK. Or actually, the first thing I need to do, I'm going to back out of that, is I need to set my sweep. So I don't want 2 megahertz to 1.5 gigahertz. In this case, I'm going to be doing a GMRS antenna or a UHF general antenna. So I'm going to go and I'm going to say 440 megahertz, just that. And I'll say up to 500 megahertz. And I'm just gonna hit sweep real quick because that'll lock in those settings. All right, now I'll come down, calibration assistant, hit OK. And it's gonna say, please connect the short. And I say, okay, let me grab the short standard, plug that in, and then make sure you're not touching this because you will interfere with it. And I'm gonna hit OK. And it's gonna do the calibration. And if you notice, it says 101 points. That is because I only set one segment to sweep. If I had set 10 segments to sweep, it would show me 1010. And now once the open, and I'll connect the open. Some people have, a lot of people have asked, when you're doing the open, do you need to connect anything to it, or can you just leave it the end of the cable? You do want to use a calibration standard for the open. I don't really understand a lot of the reasoning behind it, but it's just more accurate. So that's what I'll say for that. Do the open. All right. I love working with SMA. It is the best connector. I think everyone in this room will agree, right? You can get Nano VNAs with N-type. I think there are some with an SO239 on it. And we'll do the load. I'm only going to do the 1-port calibration for this one. I'm not going to bother with the 2-port, so I'll hit apply. And now we are calibrated. So I'll remove the calibration system. And what I'm going to do is I'm now going to take a PL259 SMA adapter. That's one of the other things when you start using this stuff, you're going to want to have a ton of adapters on the end. And we'll connect that up.
Does the adapter change the calibration?
Good question. Most people who I find to be reputable say that there's not much in terms of insertion loss with adapters, but it will affect your readings ever so slightly. To us, probably negligible. In an ideal world, I would have SMA, BNC, N-type, and PL259 standards so that I could use exactly the cable that I want to. But in my experiences messing around, it's not been much of a difference. So we'll connect that in. And before I do anything else, I'm just going to hit another sweep. And it's going to do a sweep. Now, that looks a little funky because there's no antenna on it. And you'll notice the estimated cable length is 5.505 meters. That is pretty accurate. This is a 20-foot cable. So that's pretty much on the money. It's not perfect, but it does get you a pretty close ballpark. So the next thing I want to do is I'm going to connect this antenna up to it, and then we're going to run an SWR analysis on it. Do you mind holding this for me? Sure. Yeah. And I'm going to go ahead and I am going to scroll up and hit sweep. So you'll notice, wow, this is very blown up here. What's that? So come on. Messing with my screen resolution has really messed me up here. So there we go. All right. You'll see different colors inside of the system. There's a bunch of settings. And part of that is you can actually set all of the bands for the ham bands. So when you want to do a sweep, you don't have to actually manually enter what megahertz you want to start or what kilohertz and what you want to end on. You can actually just select this and it'll pull that information up instead. So you'll notice here, this right here is 464 megahertz. And if I scroll up here, you'll see that it has a VSWR of 1.098 at that particular part. And I can move that reference point over. And as I do, you can see that the VSWR is changing and all the other information is changing as well. So in this case, you are seeing your frequency, impedance, series, LC, parallel, RX, return loss, quality factor, S11 phase, S21 gain, S21 phase. You can turn some of this information, or actually all of this information off. You can add other items. It all depends on what you want to look at. Most of this to me is gibberish. I leave it on because as I'm messing around with the stuff, I'm picking up things here and there. And this is just the default configuration. But as a result, you can see what bands it is good and resonant on. Does that all make sense? Is there any questions on doing an SWR reading?
That was great.
So I have an end-fed half wave, and I was gonna try and string it up today, and then I realized there's actually no trees. The only thing I can go to is a power line, and I'm not doing that. So I tested mine, and I've determined that my my HF end-fed half wave is good on 40, 20, 15, and 10. All of those have below about a 1.61 SWR. And then I was able to look at it all. And on my other computer, I mistakenly didn't add it to the slideshow, but I actually have the same display as like the end-fed or the folded dipole at the bunker. Yeah, and so what's nice about this is that it'll also, again, it'll show you your TDR. And in this case, it actually changed a little bit. It's now showing 8.001 because things have changed. There's also an antenna now on it. So the TDR is really the best thing to use if you don't actually have it connected to an antenna. Now we see, let's see this, let's see. Display setups. So that's actually showing, oh, it's showing return loss. So let's make that SWR. Let's see. ESWR. And I'm also, yeah, because I'm only going to do one at a time because I can only fit one at a time. And then we will sweep again. Or had I accidentally changed that? All right. We can also show Smith charts. So you'll Smith chart. I really don't understand Smith charts myself. I barely can get a handle on them sometimes. But that is the representation of what that antenna looks like on the Smith chart. And as you can see, there's a ton of different charts here. So pretty much every single trace option that you have on the Nano VNA, you have up here in Nano VNA Saver, and you can display. You can also have up to 6 of these charts at a time, 2x3 grid. You can click on the chart itself, and you can hit a pop out, so you can bring it out like this if you want to do that, or you can just save the image directly. So the screenshots that I had of the bunker one, that's how I did it. Is I connected this up to the bunker antenna. I set it to be 20 segments or something like that over the HF band, and then I did the test, and then I hit save, and it popped it out here. Any questions? Anything that people want to dive into specifically? Because I wanted to leave a little bit of time at the end for that. No? Anything that anybody has like a slight bit of confusion on, or just wants me to say again even? Okay.
Well, no, I'm used to using an MFJ 259B. So
Yeah.
that's a lot easier. You know, it's
Yeah. Yeah, I mean, if you're using an older analyzer that you got to do a bunch of knobs and whatnot, this is definitely easier. But if you're using one of the newer ones that's like, $200-300 that you plug it in and it shows you a little graph, or like the new MFJ ones that have your reading, but then also have like a digital screen and a bunch of other stuff, like those will be easier to do the SWR, but this is going to tell you a heck of a lot more information.
And cheaper.
And cheaper. I have not figured out how to do it within Nano VNA Saver for some reason, but if you use the log mag trace, you can actually connect a piece of coax from one port to the other doing your calibration, and you can actually see your dB of loss at any given frequency. So for example, LMR 400 is a lot lower loss than RG8X is. RG8X, I found anything in the HF bands was under 3 dB of loss by the time I got to 144 for this particular cable at least. It was about 5 dB of loss, and then when I got up to UHF, it was like 7 or 8 dB. LMR 400, I was able to do the same thing. It was a lot flatter, and then in the UHF range, it was actually 3 or 4 dB of loss instead. So you're getting almost twice the power out of that cable.
For that, for 50 feet,
For 50 feet versus 20 feet of the RG8X.
I'm surprised you had 3 meters off.
Yeah, yeah, me too.
Very cheap cable for HF. Other few HF.
Yeah, exactly. And that I spent, I think, $8 at a Handfest for that particular piece of cable because I just needed something cheap at the time. And for HF purposes, it serves me just fine. That LMR 400 kit, of course, came with the antenna there. Actually, I'll take that back from you. Thank you. So I had mentioned earlier, if you wanted to do calibrations to factor out this entire cable, all you would have to do, leave this all hooked up, either have the proper calibration standards, so have an SO239 set of standards, or an adapter to SMA. I don't have another female to female barrel, but if I did, I could put this on it, do the calibration, just like I showed you, and just like the Nano VNA does internally. And then this entire cable will be invisible to your tests effectively. Again, not invisible in the sense that the Nano VNA sees it, it knows it's there, it calibrates it out, but for your testing, it will be gone. So if you're, for example, doing, I know you've got a repeater, another fusion repeater that's going out soon, right?
Yeah.
So if you wanted to use this for testing out the duplexer, it's very important to take that calibration and reference plane and put it at the end of that coax cable that you're connecting in. Otherwise, that coax will affect that reading as you're doing your notch filters.
And I think if you use the tool, you know, the device in the field,
Mhm.
you calibrate the device by itself.
Yeah.
You can measure and save it, and then display it on the saver
Mhm.
as it is.
Yes.
If you measure with the saver connected,
Mhm.
you have to do a calibration through saver.
Yes. So that's a good point. The first calibration save slot will be loaded by Nano VNA saver when you start it up. So for example, I actually have I lied earlier. My first slot is actually 50 megahertz to 1.5 gigahertz. So I have a general entire range loaded into there. And then I will load up my calibration files on a per device basis. So you also might have noticed in there when I had the calibration window, or I had the load files window open, I have a 10 segment HF band, and then I have a 10 segment HF band with RG8X. And all that is I calibrated this piece of cable into that. And then I was doing tests, I was loading each of the calibrations, the with cable and without cable, and I was comparing how all of my results looked based on whether the fact that, or whether or not the cable itself was calibrated out. You can also put a micro SD card into the Nano VNA. I've had issues with mine. I've yet to get it to actually work. I think it's a formatting issue. But you can basically take screenshots and save an image and then load it up on a computer later, just like you could with the Nano VNA Saver app. So if you're out in the field and you start off in a 10 and you're just having really wonky results and you don't know why, you can save an image of that VSWR chat graph or the Smith plot or whatever else it is that you're looking at, and be able to bring somebody to be like, look at what this looked like out in the field. And again, if you're just bringing out a dipole, or you have like a Wolf River coil or something like that you have to tune every single time, you can save a couple of calibrations if you know that you're going to activate 20 and 40 meters. That's all you're going out to activate, but you know that you need to test based on those. Set yourself a calibration of just on either side of the 20 meter band and either side of the 40 meter band, load up that, tune it up, get on the air. You can operate this fairly slower than a higher end SWR meter, or if you have an older one, this one is still faster, even though there's a couple of extra steps that you have to go in and account for. But the big thing with that is make sure whatever range you're testing, you have calibrated for that range. And the number of pieces between you and the antenna that you can remove in some instances, the better. If you want to look at what your SWR is with your piece of coax, because that is what your radio is seeing, great. But if you're building an antenna and you want to make it as absolutely perfect as you can and you don't want to see the coax, or calibrate coax right out of it. Any questions? Anybody want to put their hands on it? Anything like that? Okay. Well, I hope that everyone learned something. Again, this PowerPoint will be available, and I highly encourage people to go through. I learn best from YouTube videos, so you'll notice most of the links are YouTube videos or YouTube playlists. There's a couple in there that are really, really, really good that honestly do a much better job of explaining than I can with my poor public speaking skills.
You did great.
Appreciate that.
Don't give yourself credit.
I will give myself the credit, but I will also recognize that there are people who do a better job of explaining scientific topics than myself. And that is why I wanted to make sure that you understand those references are there. Please go use them, because they're the ones who will actually teach you how to use this and become competent on it versus having a primer on it as I labeled the PowerPoint.
Can you unmute the TV? We might have some video.
Absolutely. That's not the right one. Oh, unmute the TV. Gotcha.
There you go.
There we go. Any questions from anybody remote?
No, it's been a very useful presentation. Thank you.
Thank you. Glad you were able to enjoy and you learned something from it.
I learned some stuff. That's great. Thank you so much.
You're welcome. Thank you, everybody, for indulging me.